So right now we need to talk about finding integrals when we have inverse trig functions. Actually, it's when the antiderivative is the inverse trig function. So to start, we need to recall what the derivatives of at least 3 of our inverse trig functions are. And I have a little asterisk there, so you'll find a video that goes through finding the first 2 of these derivatives. So if you have no idea where they came from, it's a good idea to take a look so that they make a little bit more sense than just, ta-da, here they are. But for right now, ta-da, here they are. So the derivative of inverse sine of x is 1 over the radical 1 minus x squared. Derivative of the inverse tangent of x is 1 over x squared plus 1. Notice no radical. And then the derivative of the inverse secant of x has this absolute value of x out front, which sometimes this absolute value might be missing. And then I have the radical, and this time the x squared is first. So those are some of our clues. So the inverse tangent, no radical, x squared is first, and it's a plus. Some things to think about, right? If you remember how to do the derivatives, just which angles go where in the Pythagorean theorem and where the plus side is. Radical. So if you really have no idea where those come from, I strongly urge you to go find a video on finding derivatives of inverse trig functions, because it's kind of cool how they all turn out. So what we're talking about today, though, is going backwards. And if we have the right sides, right, and we're asked to find the antiderivative to be able to go back. So if I want to find the antiderivative of 1 over x squared plus 1, right, I need to find, well, what function has this as its derivative, right, from the fundamental theorem of calculus. If I know what function has this as its derivative, then I know the antiderivative of this one. So if I just do a comparison, what function leads to 1 over x squared plus 1 when I differentiate? Well, that's inverse tangent. No radical, x squared plus. If I have the integral of 1 over radical 1 minus x squared, so my choices are, right, inverse tangent, inverse sine, and inverse secant. Sine has the no radical and the plus. Secant has the extra x out in front on the bottom. So this one here is my inverse sine, which leads my third and final to be, must be, inverse secant of x. So let's go ahead and try 3 examples that have just a little bit extra involved. Because as you've seen, you keep building on your techniques here. And so all of those techniques you've learned so far are still in play. We have to be able to pull those into our heads if we need to. So this first one, if I take a look at it, so I'm integrating dx over radical 1 minus 36x squared. So it kind of feels like an inverse tangent because an inverse sine. I still have my radical. My variable term is second with a minus sign in front. But it's not 1 minus x squared, it's 1 minus 36x squared. So here's what we need to do. I need to do a u sub on this one. And I really would like to have a radical of 1 minus u squared. So I need to rewrite this 36x squared to be u squared. So if u squared is 36x squared, that means u would be 6x. So I have 1 minus u squared for the bottom. But if u is 6x, then du would be 6 dx. Remember, when we're doing a u sub, the only thing we're allowed to fudge factor with is a constant. So you heard me pause there. It's like, oh my gosh, am I going to get an extra x there? But that's right. It's u squared. But du is still just 6 because the derivative of a linear function is the coefficient. So 6dx. So that I can fudge up here. Okay, here we go. Everybody here is going to get transformed in red to be u's and the fudge factor put in. So I'm going to have, under my radical, 1 minus u squared. And on top, I need to have a 6dx. So 6 up top, 1/6 out front. So the 1/6 out front carries down. And this 6dx is the same thing as du, which is what I would like to know. So now this is exactly inverse sine. So it's 1/6 from out in front times the inverse sine of u. But we were asked about x, so now we'll go back. So 1/6 times the inverse sine of 6x plus c. Okay, let's see if we can get another couple in here before we run out of time. So the second one is kind of tricky because sometimes you're going to see questions that look like this where it's a straight u sub. And you just kind of can do a quick check if you say, gosh, is that maybe u in the bottom and du up top? Because that would be great. And then it's just natural log and I write it down, or I guess it's a power rule and I can make that work out. But so if I think that u is this radicand, which is usually what, right, if you have a radical, you let u be the radicand. So derivative of that would be negative 2x. Oh, well, I've got an x, but I don't have this plus 1 kind of throws it. But that leads me to a very special trick. When your numerator has more than one term in it, sometimes you will find it helpful to split up your integral into two pieces. Oh, radical 4 minus x squared. And then you'll use a different technique on each of these fractions. Okay, so room's going to be tight here, so I'm going to scrunch in a little bit. So this first one is a u sub. If you let u be the entire radicand, 4 minus x squared, du is negative 2x dx. I've got the x. I need a negative 2. So 1 inside so that I have du. 1 over the reciprocal out front to balance. So now just working on that first fraction, it's negative 1/2 integral. What do I have there? U's on the bottom under a radical, which we know we can write as u to the negative 1/2 du, because I got all that taken care of. So negative 1/2 u power rule, 1/2 divided by 1/2. Okay. So just doing a little manipulating in here. Get rid of your 2's. I'll grab my color. I'm going to have negative square root of 4 minus x squared. That's the result of that first one. So that wasn't too bad. But now I still have my integral of 1 dx over radical 4 minus x squared. And that feels a whole lot more inverse trig-ish. So that feels like my inverse sine again. But the inverse sine, it had a 1 there. That 1 was pretty important. So if I want to make that a 1, how could I do that? And the answer is I could factor out a square root of 4, right? Okay, it's not pretty, but we can do it. Here we go. So I'm going to, let's see. let's just work that bottom a little bit. Can I come down here? I'm going to grab some green. So I'm just going to rework. Okay, I'm not going to grab green. I'm going to grab purple. I have 4 minus x squared, and I want to factor out a square root of x. I'm sorry, a square root of 4. So that would be a 1 here, and then minus x squared over 4 underneath. Do you agree that those two are the same things? Although, right, the top one's nicer. But if I look at the bottom, I have 1 minus something squared, which is, right, my inverse sine pattern that I need. And a 1 over square root 4 is fine. I don't really care about that. So when I go to do this second fraction, I'm going to have to let u be x over 2. Okay, so let's see if we can make all of that go together for this guy right here. So now I have, here I'll get my red back, the integral of, I have a radical 4 out front, under the bottom, right? So 1/2. I have dx in top still. Underneath I've got 1 minus, I'm going to call that u squared. No, I'll call it x over 2 squared. I'll take 2 steps, x over 2 squared. Okay, here we go. Can we sneak it in? So that's u. So that du would be 1/2 dx, which I happen to have exactly right there. Okay, I'm totally running out of room. So I have the integral of du over 1 minus u squared, the radical. So this guy here is the inverse sine of u, which is x over 2. And that is the antiderivative for my second fraction. Okay, I know it's terribly complicated and gobbled up in there. I should have given myself much more room. But my final answer then for the antiderivative of this guy is negative radical 4 minus x squared plus inverse sine x over 2 plus c. Here's the answer for the second one. Okay, I know this is getting long, so let's see if we can make this last one go fast. I'm hoping, as I wrote it down, I was hoping that it was going to be a u sub and a tangent, or maybe a natural log. What if I let u equal sine x? What if I just stop there? What is that looking like to you? Okay, so du would be cosine x dx. Hey, I've got that. Yay! So now, integral of, change everybody over, u squared plus 1, du in the top. Well, that's my inverse tangent of u, which is now being played by sine of x. You absolutely should take some time, draw a triangle, see if you can make that look nicer, but I don't have time, so I'll leave that for you.